Hi, welcome to the video. This video is presented by myself, Shilpa Nair and Yash Khare. The topic of our video is Artificial Neural Network for the course Deep Learning. These are the table of contents that we are going to cover in this video. What are ANN, architecture of ANN, backpropagation, example, followed by conclusion. Now, what is ANN? Artificial neural networks are a special type of machine learning algorithms that are modeled after the human brain. That is, just like how the neurons in our nervous system are able to learn from the past data, similarly, the ANN is able to learn from the data and provide responses in the form of predictions or classifications. A variety of tasks such as image recognition, speech recognition, machine translation, as well as medical diagnosis makes use of these artificial neural networks. Now, let us see what is the architecture of this ANN. There are three layers in the ANN model. The first layer is the input layer, the middle layer is the hidden layer, and the final layer is the output layer. The input layer is the first layer of an ANN that receives the input information in the form of various text, numbers, audio, image, etc. Then in the middle of the ANN model are the hidden layers. There can be a single hidden layer as in case of a perceptron, or there can be multiple hidden layers. These hidden layers perform various types of mathematical computation on the input data and recognize the patterns that are a part of it. Finally, we have the output layer. In the output layer, we obtain the result that we obtain through the rigorous computations performed by the middle layer, that is the hidden layer. In a neural network, there are multiple parameters and hyperparameters that affect the performance of the model. The output of ANNs is mostly dependent on these parameters. Some of the parameters are weights, biases, learning rate, batch size, etc. Each node of an ANN carries some weight. Now let us look into the parameters and the model of ANN in detail.
Great. This is the architecture of artificial neural networks. Here we can see there are three layers. First, the input layer, which is denoted as x1, x2 and so on. Then the hidden layer, denoted in blue color circles. Then the output layer as y1, y2, etc. So, input layer is the layer which is feeded the input or the image into multiple neurons. Now, this input layer transfers its information to the hidden layer with the interconnected lines known as weights. Now weights are assigned randomly at initial points. Now it will change accordingly in the learning phase with the help of back propagation and forward propagation, and we'll learn about it in later slides. So as we can see here, the input layer is feeding information to the hidden layers, and hidden layer is where all the computations are done, like cost functions, activation functions, and the weights are assigned. Now each input neuron also has a bias. Now the weight sum is the combination of weights and the bias. So the weights and the bias are transferred, and when activation function is used to check whether that particular neuron will be activated or not for feature extraction. Now after the first process, after the feed forward propagation, we can see that output layer, there are errors after comparing it with the original output. So the weights and the information is sent backwards accordingly, and the weights are reassigned. So here we can see this is the architecture, and let's see the types of neural networks. First is the feed forward neural network. Now exactly feed forward neural network is, as it goes with its name, it's the one direction. The network, the transfer of information goes in one direction. From input layer, the information is fed to hidden layer, and after computation is done, the hidden layer gives the output to the output layer. There is no backward propagation is there. The information goes in single direction, in only one direction. So let's see the second type of neural network, that is feedback neural network. As we have seen that in feed forward, the transfer of information is only in one direction, but here in feedback neural network, the transfer of information is in both types, like feed forward and back propagation, and it helps in reassigning the weights, and the accuracy is much higher. So it is, but as there are multiple iterations of books, there are chances of complications. Now let's exactly see what is backpropagation. So backpropagation is the essence of neural network training, because as we have said, the after comparing the errors with the original output, the information is sent backwards and the weights are reassigned. The fine tuning is done in the weights with the particular number of iterations. Now, after proper tuning of weights, the accuracy or the model will give a good accuracy. So,
So this is an example. So let us consider that we need to build a neural network for which we need to identify the image input is a square, circle or a triangle. So we would see that the circle, we made this picture into a 28 into 28 array which gives us around a 784 pixels. To identify or classify this image, what artificial neural network does is this first is the input layer, and we can see that there are 784 inputs given to this neural network. What this happens here is that this input layer passes on the input by applying some weight to the next hidden layer. Hidden layer has some activation functions and forward propagation happens, and then there is some output at the output layer. The error function is calculated, and we can see that for these are the error functions. These error functions are kept in mind and backpropagation is done. Backpropagation helps us to adjust the weights and give a clear output. After the number of times this forward and back propagation happens, we would get some other error functions. Again, back propagations happen. This happens for million number of times in just a seconds. And when this forward and back propagation happens, and at the end, when we get a clear output, we can see that the neural network gives 0.9, which means 90% probability that this image has to be classified as a circle. Here we can see the error function is minimized. So forward propagation and back propagation happens, still the errors can be minimized. So this is how this artificial neural network works to classify an image into the possible outcomes. Let us see a few applications of ANN. We can see the use of ANN in facial recognition, stock market prediction, social media applications, aerospace, defense, healthcare, signature verification, handwriting analysis, and many other applications. So, while coming at the end of this video, we conclude that artificial neural network uses the processing of the brain as a basis to develop algorithms that can be used to model complex patterns and prediction of problems, for example, image classification. This presentation included what are neural networks, what is the architecture of neural networks, what are the types of ANNs, what is backpropagation. At the end, we saw a few applications of ANN. Thank you so much for watching the video.